Today we're going to cover section 7. It's going to be surface area and volume of cones. So first, here is a picture of what a cone looks like. Now, the cone is composed of a base, which is a circle, and then it's going to have the lateral area that's going to connect the vertex with the points on the base edge. In this picture, we're going to have a height, and we will also have a slant height. So for the volume, we need the height, but for the surface area, we're going to need to know the slant height. So let's go ahead and take a look and see what the formulas are. So this is the picture down at the bottom. I don't know if in middle school they talked about nets, and that's when if you were to take the solid and unfold it, this is the shape that would result. So the base is the circle, and then the lateral area is like it's the area of a sector. So to find the lateral area, you're just going to multiply pi times the radius times the slant height. Then for the total surface area, it's going to be the area of the base plus the lateral area. And again, remember your base is a circle, so it's pi r squared. And then the lateral area is that pi rl. So again, the L is the slant height. Pretty good there? So let's see the volume formula. The formula for volume, very similar to that of a pyramid. Again, it's the area of the base, which is a circle, pi r squared, times the height of your cone, and then either divide by 3 or multiply by 1/3. So that is your formula for volume. So again, volume of any shape is always the area of the base times how tall it is. But if it's a cone or a pyramid, we need to multiply the final base times height by multiply it by 1/3 or divide it by 3. So let's try some examples. So they're going to walk us through step by step. So the capital B, remember that's the area of your base. So we can see that our base shape is a circle. So the base is pi r squared. My radius in the picture is 5. So this is going to be, the 8 here is the slant height. The 5 is the radius. So pi times 5 squared gives me 25 pi. So if it asks you to leave it in terms of pi, that would be that answer. However, if it says to round to the tenths place, this is 78.5. And these are meters squared because this is area. For the lateral area, the formula is pi r l, where L represents the slant height. So in terms of pi, 5 times 8, and in terms of pi, it's going to be 40 pi. But if I multiply it using my pi button, I get 125.7. And again, these are still meters squared. For the total surface area, so if you get a question where it says find total area or surface area, the SA stands for surface area. We're going to find the area of the base and add it to the lateral area. And that's what I just calculated in A and B. So again, my base shape is a circle, and that area was 25 pi. My lateral area is 40 pi. If I add them together, in terms of pi, the answer is 65 pi. But if it says to use your calculator, then I'm going to multiply 65 and then hit the pi button. 204.2 meters squared. We still have squared. We're still doing area. And now lastly, the volume. The volume formula is 1/3 capital B times the height of the cone. Now notice we don't know the height of the cone. So we need to do Pythagorean theorem to find the height of the cone. So the height is located over here. Remember, it's that perpendicular distance. So if I pull this little right triangle out of here, I know this leg is 5. I know this slant height is 8, which is my hypotenuse. And now I'm looking for the other leg, or the height. So I'm going to do h squared plus 5 squared equals 8 squared. H squared plus 25 equals 64. Subtract 25. H squared equals 39. Square root it, and the height is the square root of 39. Now, if I could break it down, I would, but I can't because it's just 3 times 13, no perfect squares. So now I can plug it in. So I'm going to do the volume is 1/3. The area of my base was 125. Let me go ahead and just put it in there as, instead of putting it in as 25 pi, I'm going to put it in as 78.5. And then I'm going to times it by the square root of 39. The volume, 163.5 meters cubed. Pretty good there. Now, if you'd rather put it in as 1/3, 25 pi, and then times root 39, you can do that as well. But just remember, it's the area of the base times the height, and then times by 1/3 or divide by 3. Let's try another one. We're going to do exactly the same thing. Then we'll do similar, and then we'll do a composite. Same thing that we've done all along for the other solids. Pretty good? Okay, let's try this example. So this time they're giving us a diameter. So I need to turn that diameter into a radius. So I'm going to split the 24. And the radius of my base is going to be 12. Again, notice they're giving me the slant height. Now, if you want to, before we even start, we can go ahead and find the height. Because again, we're going to form a triangle here. And this one's actually a triple. But again, if you don't know your triples, we'll go ahead and do Pythagorean theorem. We're going to do h squared plus 12 squared equals 13 squared. 12 squared is 144. 13 squared is 169. Subtract the 144. H squared equals 25. Square root it. And the height of the cone is 5. Now I have everything I need to calculate A, B, C, and D. So again, for the base is a circle, so pi r squared. Again, we turn that diameter to a radius by dividing it by 2. So pi times 12 squared is 144 pi. And then if I'm asked to use my calculator, 144 pi is equal to 452.4 meters squared. For the lateral area, that formula is pi r times the slant height, which is the L. And again, they gave me the slant height. I didn't have to do any calculations for that. So pi times 12 times 13. So in terms of pi, 12 times 13 gives me 156. So in terms of pi, the lateral area is 156 pi. But if I use my calculator, I get 490.1. And let's go here. 490.1. And again, the units on this are meters squared. For the surface area, I'm going to be doing pi r squared plus pi rl. Remember, we're doing base plus lateral area. So we already calculated it above. The base area was 144 pi. The lateral area was 156 pi. Adding those both together gives me 300 pi. Using the pi button, 942.5 meters squared. For the volume, 1/3 base area times the height. I already took the time to find the height to begin with. It was 5. And I already calculated the base in answer A. So volume is 1/3, 144 pi times 5. And the final volume here is 240 pi, using the pi button, 754.0 meters cubed this time, because it's volume. So again, finding the volume of similar solids. So again, they'll start out by telling you that they're similar. We need to find the scale factor, and then from there we'll cube it, and then we can use it to find the missing volume. So again, just stay consistent here. So for the scale factor, we'll call it K. I'm going to set mine up as the radius of cone B over the radius of cone A. 9/3 simplifies to 3. So then to take the K, and if we cube that, K cubed is 27. And that's what we're going to use to find the volume. Now, notice how I did B over A. If you do A over B, you got to do the same thing on when you do the volume. But I'm going to do the same thing. I'm going to do volume of B over volume of A. And I'm going to set that equal to the K to the 3rd power. So the volume of cone B, I don't know. And then the volume of A is 15 pi, and I'm going to set that equal to 27. And now what I need to do is solve. And again, what I can do is either treat this as a proportion. I could add a 1 to the bottom, or I can just say I'm going to multiply both sides by 15. And I get x is equal to 405 pi. If I use my pi button, 1,272.3, and these are both feet cubed. Now, if you'd rather add a 1 and then cross multiply and divide, you can set it up as a proportion as well. The last one is the composite solid. This may be more like the ones we've been doing in the notes will be more likely similar to questions you would have on the test. Nothing as complicated as that nautical figure that we did in the homework. Pretty good with example 3. Let's try example 4. So this composite solid here is a cylinder and a cone. So to find the volume of this composite solid, what we're going to do is find the volume of the cylinder and add it to the volume of the cone. So for the volume of the cylinder, remember it's just base height. This one's 1/3 base height. The base of the cylinder is a circle, so pi r squared times the height. And this is let's label these numbers. So the 3 is the radius. The 10, I'm gonna call this height number 1, because this is the height of the cylinder. And then the 5, I'm gonna call that h2, because that's the height of my cone. So I'm gonna be doing pi r squared times the height 1, which is the height of the cylinder. And then this one's gonna be, again, pi r squared for the base, times its height, which I labeled as height 2. So the radius for both is the same, it's 3. So pi times 3 squared times the height, which is 10. And then here 1/3, 3 times its height, which is 5. This gives me 90 pi. This one gives me 15 pi. So this needs a square here. And then add them together in terms of pi, 105 pi centimeters cubed. But again, if you are using your calculator and it says to use the pi button, 329.9 centimeters cubed. And that is it for volume and surface area of cones.